Now, 33rd question. The following definitions correspond to different types of price discrimination. Link them correctly. Well, I took these definitions from Varian, from the book. Okay, so my goal with this question is to have clear, okay, what does exactly mean each type of price discrimination, because sometimes it's not easy to distinguish them. Okay, the monopolist sells different units of output for different prices, but every individual who buys the same amount of the good pays the same price. Thus, prices differ across the units of the good, but not across people. I told you when in this video or the previous one we had the airline, yeah, no, the phone company, sorry, charging different prices through weekends and okay. The most common example of this is bulk discounts. Okay, so it's a second degree price discrimination. Yeah? The monopolist sells different units of output for different prices, and these prices may differ from person to person. This is sometimes known as the case of perfect price discrimination. So this is first degree, of course. Yeah, maybe it seems to be D, yeah, here. Okay, now the monopolist sells its output to different people for different prices, but every unit of output sold to a given person sells for the same price. This is the most common form of price discrimination, and examples include senior citizens discounts, student discounts, and so on. Well, clearly this is third degree, and we should mark D here, yeah? Okay. Monopoly with a total cost equal to fixed cost plus ZQ, so it's a linear total cost function that faces the demand Q equal to 50 minus P halves, maximizes its profit at P equal to 60. How much is C? Well, it seems to be difficult, but this is very easy. In fact, I think that we have this type of questions in the first course in Principles of Micro. So we just do it the same as always, as we do always, and the difference is that now we have C as an unknown and P is the data, yeah? So we, of course, first of all find the inverse demand. Okay, so from here we isolate P, we have 100 minus 2Q, and then profit maximization condition, 100 minus 4Q equal to marginal cost, that is C. C. I was thinking about this 4, I suppose. 100 minus C equal to 4Q, then Q equal to 100 minus C divided by 4. Okay, with this quantity, the monopolist goes to the demand, the inverse demand, that is 100 minus 2 times this. Okay, we do the appropriate calculations to isolate C. Yeah, for example, we simplify these 2 with the 4, 100 minus C divided by 2. Then we multiply everything by 2. We have 120 equal to 200 minus 100 minus C, and C on the right hand side is equal to 100 minus 200 plus 100, that's 20. Okay, so this is the correct one. Perfect. Now 35th. A monopoly with this total cost has a producer surplus of 30 after maximizing profit. How high are these profits? Okay, this is a great question. I usually tell you that there is a strong relationship between the profits and the producer surplus, that we use it commonly in monopoly, because in monopoly the unique producer is a monopoly, yeah? So the profits, you must remember this, profits are previous surplus minus fixed costs. Okay, then previous surplus is 30, fixed costs are 50, then profits are minus 20. Okay, well, oops. Okay, so I like this type of questions. I hope if you find in the exam or whatever this type of questions, you know how to answer them. Natalia is a monopolist in the salt industry in her small country, where there are two types of consumers. There are 10 firms with which use the salt as an input to produce food and so on. Each one with individual demand curve P equal to 40 minus Q divided by 100 and 1000 families, each of them with demand function, this one. Its cost function is this one, 100 plus Q, the cost of the monopolist, yeah, of Natalia. For Natalia, it's not difficult to distinguish both types of consumers because firms can't pretend to be families and families can't resell sold to firms. Okay, then her profits are, well, this is clearly third-degree price discrimination, so let's do it. Okay, from firms we isolate Q to aggregate and find the firm's aggregate supply, aggregate demand, sorry. So from P here, from firms, we isolate Q, we multiply by 100, then 4000 minus Q is equal to 100 P. We isolate Q and it's 4000 minus 100 P. Okay, now we have 10 firms. Then what will be the demand of all the firms together? 10 times the demand of each of them. Okay, so for okay, here's a little mistake. This is P. Okay, this is P from here. Okay, 10 times this is 40,000 minus 1000 P. Sorry, this is P. Then if we isolate P, and this P, we have 1000 P equal to 40,000 minus Q, then P equal to this. Okay, then marginal revenue is 40,000 minus 2Q divided by 1000. Well, I don't need the price range because I'm not going to aggregate, yeah, because I'm going to practice price discrimination. Okay, families, this is the individual demand from families, so each family's individual demand, and as they are 1000 families identical, we multiply, and 10,000 minus 1000 times this is 500p. So if we isolate p, is 500p equal to 10,000 minus q. So p is this at the end, and the marginal revenue where the trick is 10,000 minus 2q divided by 500. Okay, then we apply that marginal revenue for firms equal to marginal revenue for families equal to marginal cost, that it was 10. 10 was no 1. Okay, here we have marginal revenue for firms equal to marginal revenue for families equal to marginal cost, then 1. So we isolate q for firms, q for families. Okay, we pass multiplying 1,500 here, and then isolating properly is q equal to 19,500 for firms and 4,750 for families. So in total 24,250 units are sold. Units of sold are sold. So the price, we go with these quantities to each inverse demand, Okay, this inverse demand, we could find them here. Okay, here for firms, here for families. So there we go with our quantities. Okay, we substitute these quantities and we find 20,500 divided by 1000 is 20.5. Okay, from families we have the 5,250 divided by 500 is 10.5. So now profits, revenues from firms and revenues from families minus my costs. Okay, was 100 plus Q. So these are the profits for 125,000, etc. Okay, this is an easy, typical third-degree price discrimination exercise. You shouldn't have problems with it. 37th. Paula, you are a monopolist and you may choose between two technologies. The first one is capital intensive and it yields the cost function just 500, while the second one is labor intensive and yields the cost function Q squared. Okay, the demand faces, the demand you face, I should say, if the demand you face is 100 minus P, you will choose, okay, we just have to do the exercise twice. Yeah. First of all, if I am Paula, I do this exercise, okay, my profit maximization exercise with this type of cost, and secondly, with this type of cost, and choose how, in which situation I earn more. That's all. So demand 100 minus P, inverse demand then P equal to 100 minus Q, marginal revenue 100 minus 2Q. Okay, here the same, and in the first situation marginal cost 0, in the second situation marginal cost 2Q. If we solve them, Q is equal to 50, then price is 50 going to the inverse demand, and profits are 2,500. Okay, then with the labor intensive total cost function or technology, we have this Q, less quantity, more expensive, yeah, and the profits are these other revenues minus this cost is 25 square, so these ones. Then Paula, we should choose capital intensive technology. Okay, then if you find this type of exercises that you can think that they are new, that we usually don't have this type of exercises, just read them again and just do them. They are easy. Now, Paula, from the previous exercise, you realize that due to a negative shock, the demand shifts to the left, becoming 50 minus P. You will choose which one. Okay, it's the same exercise. I just did it, so you do the same. Okay, you do exactly the same. But now, as you can see, the labor-intensive technology is more profitable for you. Okay, why did I do this exercise? To learn that when we have fixed cost or high fixed cost, maybe it's better if we produce more, or if we have high demand to be able to produce more. Yeah, but if we produce less, well, with so high fixed cost, okay, and well, that's the story. Okay, so we should mark B. Yeah, perfect. Now, 39th. Which of the following statements is false about the learner index? Okay. Let's learn what the learner index is, I usually explain you in class. We do the differentiation of the total revenues, and we find that well, 1 divided by the elasticity, the inverse of the elasticity, it's important, okay, in the decision of a monopolist. So that index, that's a number, we call it learner index. Okay, so the higher the elasticity is, okay, so the more elastic the demand is, the lower the learner index is. Okay, so if we this is the profit maximization condition, how it stands as a function of, or depending on, the price elasticity of demand. Okay, I usually prove it to you in class. Okay, now if the higher the learner index is, the higher this number, the higher could the price be. Okay, the higher the learner index is the same as the lower the elasticity, so the more inelastic demand. There is where a monopolist could charge a high price. Yeah, so the higher, the more market power. Well, I think that is sorry, it was false. I was saying, oh, this is true, yeah, but this is also true by definition. Okay, so I was like okay, so which is false? This is true. The profit maximization condition stands as follows. Yes, because we prove in class that we can write it like this, and as by definition the inverse of the elasticity is L, then L is equal to this. Okay, so this is the false one, of course. The lower the learner index, the higher the monopolist profits. No. So 40. A monopoly with marginal cost equal to 7 faces the demand minus q squared plus 10 equal to p. Be careful, this is a quadratic inverse demand function. What price will the monopoly charge if it charges a unique linear price? Well, we do it the same, but without the trick. Okay, we can't use the trick now. So we have the total revenues and we must differentiate them. Okay, then our revenues, price minus q squared plus 10 times quantity. So here, yeah, here. And we equalize it to marginal cost is 7. So if we differentiate this, is minus 3q squared plus 10 equal to 7. Then 10 minus 7 is 3 equal to 3q squared. So q equal to 1. And if q is 1, we go to the demand as always, and price should be 9. Okay, so as you can see, we usually see or have linear demands, but if we don't have linear demands, the exercise is the same, of course. We just can't use the trick, of course, but oh, sorry. Well, see. Okay, which of the following is not an example of third-degree price discrimination? Osasuna charges different price to men and women for its next match tickets. Of course, this is a third-degree price discrimination. This code charges 10 euros for the entrance and 13 euros if you buy the entrance plus a shot. Be careful, this is not a third-degree price discrimination. Okay, you may choose this or this. Okay, when you are a man, you can't choose the entrance of a woman. Okay, this is second degree. This is like bundling. Okay, that we don't see, but the concept, I think it's easy and you should know it. Gallardo Theatre charges children below 12 half of the price the rest of the spectators pay. Yes, of course, this is third degree price discrimination. Renfe charges you a lower price if you belong to a large family. Of course, this is This is a third-degree price discrimination. Okay. Now I think there are only two left. Brian is CEO of Cerveza Cusqueña, the most famous beer in Peru. The beer is sold all over the world at a competitive price of 200, but the firm is the unique firm in Cusco, so it acts as a monopoly in the labor market there, because if someone wants to work in Cusco, the only place to work is the brewery. The supply of labor in Cusco is given by W equal to 100 plus 10L plus L squared. And the quantity of beer produced is a function of the labor force. Okay, how much labor should Brian hire? Okay, clearly, I think clearly. Oh well, it said here. It was said here. Sorry, it's monopsony. Yeah. Let's remember from class how we calculate we do the monopsonist, sorry, profit maximization problem. Okay, price is 200, protection function is this one minus the supply times L. Okay, then if you don't want to remember all the conditions, you can just make like in calculus. Okay, you just calculate the profits and differentiate them. Okay, then if you differentiate this, is 200 constant, yeah, multiplicative constant, then 20 minus 2L minus here is 100L, differentiation is 100 minus 10L squared, so minus 20L minus L to the third, so 3L squared. And by doing appropriate calculations, if I'm not wrong, the result was 874. Okay, so this should be the price that Brian should the price, now the quantity of labor that Brian should hire. Okay, now suppose a monopoly knows not only the demand of its output, but the reservation price of each consumer. If the market demand is 30, here is Q equal to 30 minus P, its revenues will be, okay, be careful, revenues, be very careful. Okay, so I think we need the costs. Yeah, I think we need the cost. So yes. Of course, if we don't have the cost, we are not able to determine until which quantity we should sell. Okay, so here there's not enough information. Okay, well, that's all from Monopoly. I think it was a little bit of everything. Yeah, easy questions, tricky questions, well, exercise type questions, theory, definitions. Okay, I hope it's very useful for you. Okay, bye bye.